Number 21. Determine whether the sequence 32, 16, 8, 4 is arithmetic, geometric, or neither. Okay, so here we go. 21. The series is 32, 16, 8, and 4. Okay, so the first thing we're going to do is we're going to check arithmetic. Okay, if you take 32 minus 16, it's actually 16 minus 32. You're moving in the negative direction 16 places. So here you go down 16. Here there's a difference of negative 8. And here there's a difference of negative 4. So we know it's not arithmetic. So now let's see if it's geometric. Okay? And by geometric is you would take, let me rewrite this here. Geometric, remember you're going to take this term and divide by this term. This term divide by that term, and this term and divide by that term. Okay? So we have 16 over 32. 16 over 32 is 1/2. And remember, you just put it in the calculator as that 16 divided by 32. And then you can hit math, enter, enter, and it'll give you the fraction. Okay? And then we have 8 over 16, which is 1/2. And 4 over 8, which is 1/2. All right, so if we have a common ratio, then we have a geometric series, and it says explain, because we have an R, which is a common ratio. Okay, number 22. Determine whether 2, 5, 9, 14 is arithmetic. So it's just asking, is this one arithmetic? So let's see. If you go from 2 to 5, you add 3. From 5 to 9, you add 4. And 9 to 14, you add 5. So does that have a common difference? The answer is no. Okay. Is it arithmetic? No, it's not arithmetic. We're done with that problem. 23. It says, find the next 3 terms in the arithmetic sequence 5, 9, 13, and 17. Okay, so 23, we need the next 3 terms, and they said it was arithmetic, which means we have a common difference. We're either going to add and subtract. So we have 5, 9, 13, and 17. 5 to 9 is plus 4. 9 to 13 is plus 4. 13 to 17 is plus 4. So 17 plus 4 is 21. 21 plus 4 is 25. And 25 plus 4 is 29. So your next 3 terms are 21, 25, and 29. All right. Number 24. There, I can write those down. 21, 25, 29. All right, 24. It says, find the 15th term in the arithmetic sequence. A to 1 equals negative 3 and D equals 2. Okay, so first I have to find what is the 15th term. Okay, that one I don't know. I do know that is arithmetic. I know that A1 equals negative 3, and I know D equals 2. Let me pull this here so we can see it. All right, so to do this, what I'm going to do is I'm going to go to the sequence page, and I'm going to find the nth term sequence. Okay, we're going to go to sequence, arithmetic, and we're going to find this nth term so we can just fill in a 15 for our n's and figure this out. Okay, so what is our sequence? Our sequence is AN equals A1 plus N minus 1 times D. Okay, so here we go. Let's highlight our D's. And we're going to highlight A1. Okay, now we also know that N equals 15 because it asks us for the 15th term. Okay, so we're just going to fill in what we know. A to the 15th equals negative 3. Oopsie, I need to say plus. 1 second. Plus 15 minus 1 times 2. negative 3 plus 14 times 2, negative 3 plus 28. So a to the 15th equals 25. So your answer is 25. All right, number 25. I can write that here. A to the 15th equals 25. All right, number 25. Number 25 says, find the next three terms of the geometric sequence. So now it's telling us that there's a geometric sequence, okay? So we know it's a geometric. And they want the next three terms. Okay? So what are our numbers? Negative 3, negative 12, negative 48. How do you find geometric? You have to have a common ratio. So we're going to take that number divide and that number and divide by that. So let's write out negative 12 divided by negative 3. So in our calculator, we type in negative 3 or negative 12 divided by negative 3 and we get a positive 4. And we're going to try it again, a negative 48 divided by negative 12 is another positive 4. Okay, so what are we going to do? Well, this meant this was times 4 and this was times 4. So we're going to take 48, negative 48 times 4. Negative 48 times 4 is negative 192 times 4. Negative 768 times 4. Negative 3,072. So those are your next three terms. All right, so let's write those down. 3 problems left. Here we go. We're almost done. Okay, so we have, sorry, I messed that up. Negative 192, negative 768, and negative 3,072. Okay? All right, 26. Okay. 26 says, multiple choice. What is the 8th term in the geometric sequence? All right. So, what do we know? Well, we know it's a geometric sequence. We know by looking at our sequence cheat sheet for geometric, we're going to use a to the n equals a1r times n minus 1. Okay, so we know we have an equals a1 r n minus 1. We know our sequence is negative 2, 10, and negative 50. So now we have to find our common ratio. This number divided by this number divided by that number. 10 divided by negative 2 is negative 5. Negative 50 divided by 10 is negative 5. So r equals negative 5. Our a1 okay, first one in the sequence is negative 2. So now we're going to fill this in. So we have an equals negative 2 times negative 5 to the n minus 1 power. And now it did ask for the next, oh wait, hold on, what did 26 say? What is the 8th term? So now n equals 8. Okay, so we have a to the 8th equals negative 2, negative 5 times 8 minus 1, negative 2 times negative 5 to the 7th power. So we're just going to type that in here. Negative 2 times negative 5 to the 7th power. And you get 100 and, oh, I did that wrong. Oh, see, there's the mistake. I did not put a parentheses around my negative 5. It is actually negative 2 times, open parentheses, negative 5 to the 7th. Oh, I have a negative times a negative. Sorry. Negative times a negative is a positive. Okay, so we're still good. But still put in your calculator like this instead of like this, just in case this is like an even number. That's going to make that a positive instead of a negative. All right. So a to the 8th is 156,250. All right. So let's write that down. Number 26. The answer is actually C here. 156,250. All right. Last two problems. Let's finish this up. Write the recursive formula for each sequence. Okay, so this isn't giving me anything but a sequence, and it's telling me to write the recursive formula. Recursive formula, the first step is determined as arithmetic or geometric. Okay, so let's do that first. 27. We have 3, 20, 37, 54. Okay, so first we're going to try arithmetic. If you go from 3 to 20, you add 17. From 20 to 37, you add 17. From 37 to 54, you add 17. All right. Well, then this is a arithmetic sequence. So now, we know it's arithmetic. Let's look at the second step. We're going to use the formula for arithmetic. AN equals AN minus 1 plus D. Okay? So let's write that down. AN, let's see, let me pull this up there. AN equals AN minus 1 plus D. All right. Now, we know that our common difference is a plus 17. Okay. So, the first part, so we've done step 1 and step 2. Step 3 says, write the first term, the recursive formula, and the domain for n. Okay, well, let's fill this in real quick. So there's our recursive formula. But it says first you have to write the first term. Well, the first term was 3. So A1 equals 3. Our formula, we want to bring this down. AN equals AN minus 1 plus 17. And then we'll say if n is greater than or equal to 2. Okay. Now, let's look at number 28. Okay, 28, there is another mistake. Sorry. There's another mistake, and I want you to, we're just going to pretend like that negative 1/5 is not there. And we're just going to use the series 125, negative 25, and 5. Okay? So that's what we're going to do. We're going to use that series. Okay, so now we're going to have to write the recursive formula for this. So we have 125 to negative 25 to 5. Well, if you go from 125 to negative 25, you actually went down 150. And then once you go down to 150, you're coming all the way back up to the positive because now you're going to add 30. Well, that's for sure not a recursive formula. So now let's try it's not going to be arithmetic, so let's try geometric. Well, geometrics, you take this number over this number and this number over this number. Okay, so let's try that one. Negative 25 over 125. So let's put that in the calculator. And then we'll hit math, enter. We get negative 1/5. So let's go 5 over negative 25. Well, this one we can see is going to be negative 1/5 also. So our R is negative 1/5. Okay. So we have a geometric sequence. All right. So like I said, the recursive formula said first, find out if it's arithmetic or geometric. Well, we found out it's geometric. So now we're going to use this equation, n equals r times a n minus 1. Okay, and then we'll write the first term recursive formula in the domain for n. So let's write our formula. A n equals r a n minus 1. So what are we going to do? We're filling in r with negative 1/5. Or you could use negative 0.2. I'm fine. If y'all want to use that, we'll use negative 0.2. So you can say r equals negative 1/5. It also equals negative 0.2. All right, so we have AN equals negative 0.2, and put that in parentheses, AN minus 1. So now let's write the recursive formula. A1 equals 125, comma, AN